Well, hello everybody. Chef Decker here with your weekly culinary math video. This week in class, we are working on scaling factors, or maybe if you're watching this, you're working on scaling factors where you are and you could use a little extra support. So here's hoping that the information in this video will help students all over to be able to understand the information better. So let's begin by talking about scaling factors, and then I'm going to switch and I'm going to end with concentrating on how to interpret these crazy word problems. Word problems seem to be one of the biggest challenges to my students anyway. My students tend to do great if they're looking at columns. Here's the recipe quantity revised to this. That's easy. But the challenge in the word problem is that you have to apply critical thinking in these kind of fictitious situations to decide what is the problem asking me to do, and then what steps do I need to take to do that. And the word problems are meant to kind of be like an issue or issues that you would probably face in the industry if you're working. So let's start talking about scaling factors. First, what is a scaling factor? Well, a scaling factor is simply going to be a number less than 1 or greater than 1 that we will multiply all the ingredients in a recipe by in order to either make more of the recipe or less of the recipe, or to use up a particular amount of ingredient. I'm sure you've all been there. You've got your mise en place out, you're ready to make cookies, and you look at everything and you think, oh shoot, the recipe calls for 4 ounces of chopped bittersweet chocolate and I only have 2.5. Now I can't make it. Well, yes, you can. You just need to come up with the scaling factor, and then you need to multiply every other ingredient in that recipe by your scaling factor so that they're all in good relationship with each other, so that these brownies, let's call them, turn out just as good as if you made the full batch. Okay? So that's a quick explanation on scaling factor. When you solve for your scaling factor, remember, don't put a unit of measurement or volume after. When you solve, you put up your equal sign, and you don't want to write something like 4.7 ounces. Well, it's only a factor we're going to multiply by. So there's no unit of measurement involved in a scaling factor, so get that straight, okay? So the second thing that I want to talk about when we're dealing with scaling factors is there's a synonym that's used a lot in culinary school for scaling factors. So I don't want you to get confused or frustrated or nervous if you see it. The other phrase that is used when we're talking about scaling factor is recipe conversion factor. So if you see scaling factor or RCF, SF, RCF, same thing. Don't get nervous. It's going to be the same problem, the same formula, and it'll do the same thing. It'll give you a number less than or greater than 1 to multiply all the ingredients in that recipe by to either come up with more or less, or to use up more or less of a particular ingredient in that recipe. Okay? That sounds good. Now, let's talk about these tricky word problems, and I want to talk to you about a few words that are often seen in there. Okay, so the first word that we see all the time in these word problems, especially in this scaling factor chapter, is calls for. Okay, and when the word problem is going to say calls for, I want you to immediately write next to that the word ingredient. And I'm going to draw out a recipe here to show you what I mean. If it says makes, then I want you to immediately write above it the word yield. Okay, and if it says need, then I want you to write the phrase desired yield. So let me show you what I'm talking about. And this has really helped a lot of my students, so I'm hoping that it will help you as well. When you're looking at these word problems, remember, we're coming up with a number to multiply items in a recipe by. So let's look at the recipe as we're trying to solve these word problems. So let's say that this is my recipe. Okay? And let's say that we're going to make brownies. Okay, so there's my recipe that I'm looking at. That's what I'm going to make. That is the name of this recipe. Now, the professional kitchen will have a word here that says yield. And then it may say something like 2 dozen. okay? Then after that, it will say ingredients. And then it'll list ingredients, okay? It might say something like 1 cup AP flour, 10 eggs, 7 cups of sugar, 1 pound unsweetened chocolate, and 1 pound butter. Okay, and that's pretty much a basic. It's a big pan. You'll get a big sheet pan of brownies, but that's a pretty good recipe for like really chewy brownies. Okay, so if we're looking at a word problem and they're asking us to do something with this, and they say the recipe makes, well, makes is the word that means yield. So when you're deciding, are they asking me to calculate a scaling factor based on constraining ingredient or based on yield? If you see makes, you're already talking about yield. Okay? Now let's say that it says, for a party you are catering, you are going to need 6 dozen brownies. So now we see the word need. Okay, 6 dozen is what we need. Now need, I want you to remember, is going to be desired yield. Why? Because that's how much you desire this recipe to yield or make. Okay, so in this case, if scaling factor equals desired yield divided by recipe yield, you are going to take 6 divided by 2, and you are going to get a scaling factor or recipe conversion factor of 3. Okay? Now what does that mean? Well, that means that now we are going to apply this scaling factor and we are going to multiply everything in the recipe by 3. When we do that, all of these ingredients will be in good relationship with each other so that the larger recipe works out. And when we do that, instead of yielding or the recipe making 2 dozen, we will get the 6 dozen that we need. Okay? Now I'm going to show you another way to look at this. Okay, so we have this same recipe, okay? Now, the recipe says that your recipe for brownie calls for. When you see calls for, I want you to remember that means ingredients, because to make this, the recipe will call for all of these items. So if it says the recipe calls for 1 pound of butter, but you want to use up 3 pounds of butter, okay? So calls for, you want to use up 3 pounds. That means constraining ingredient. Why constraining ingredient? Because we are constrained by the fact that we want to use up 3 pounds, okay? Maybe we have some butter that is getting near to the end of its shelf life, still good quality, but we want to use it. Brownies are a big seller, so we know that we could make a larger batch of brownies using up the butter and sell them and create revenue with this butter. So calls for is ingredients, so your recipe calls for 1 pound, but you want to use up 3 pounds. So that formula for scaling factor equals constraining ingredient divided by recipe ingredient. So in this case, the problem becomes 3, we're constrained by 3 pounds, divided by 1, and now we get the same answer. 3 divided by 1 is 3. So now the same thing will happen. We'll multiply everything in here by 3, and you'll see that magic happened. We used up 3 pounds of butter, but then we also used everything in relation to each other so that the brownie recipe turns out good. Now, I want you to think about one thing. I used nice, easy whole numbers in this example. Sometimes they're not nice, easy whole numbers. You may want to use 1.25 pounds of butter. Okay, you might. Or you might look at this and you might say, oh my goodness, I only have 0.75, 3/4 of a pound. So now you're dividing 0.75 by 1 and you're getting a factor that's not a nice round number. And that's okay. I want you to round scaling factors to 2 places. Okay, round up to the 2nd place or the 100th place if we're talking about a decimal. And then multiply everything by that factor. And remember, if it's a factor greater than 1, you are increasing the recipe. If it's a factor lower than 1, you're decreasing the recipe. So just double check and make sure that logically your number that you got makes sense for what task the word problem is asking you to do. All right, have a good rest of your week. Reach out to me if I can help you with any of your homework, and I will see you all soon.